our objective for this video is I can classify real numbers, and what we're really doing is we're expanding on the idea of rational numbers. We talked about rational numbers, um, and rational numbers are just one part of real numbers. So we're gonna, to do this, and this is in your book as well. If you want to look at page 15 in your book, it'll have this as well. But we're gonna just make a box. And some of you have seen this before. Apparently I can't make a box. Some of you have seen this before. We did go over this last year, and I went over it with one class this year. This will just, so we have this box, and everything in the box is a real number. Okay? But we have this divided. So over here we have, even though this is the small box, we have the long words. So these are our irrational numbers. Okay, irrational numbers. And in here we have things like pi and tau, which tau is just 2 times pi, are not perfect square roots. So anything that's not a perfect square, if we have a square root of 2, square root of 3, square root of 15, these aren't perfect squares, and so they are irrational numbers. Any of these could be negative as well. Let's make the negative the square root of 15. Okay, any of these are going to be irrational numbers. When we see them in decimal form, they are something like pi, which is 3.14159, and then goes on forever and ever and ever without repeating, and so it can't be written as a ratio of 2 integers, and it's not a rational number. So these are our irrational numbers. There's infinitely many of them, but relative compared to how many rational numbers there are, there's not a whole lot. Okay, over on this side we have rational numbers. And we talked about how there are different kinds of rational numbers or different ways of identifying them. Within rational numbers, we also have what are called integers. And then within integers, we have our whole numbers. And our whole numbers are our positive counting numbers, including 0. So 0, square root of 4, because that's 2, right? 3, 5, any of those numbers, those are all whole numbers. There's no decimal after them. There's no fraction. We can write them as fractions, like 3 over 1 is a whole number. But if we start trying to divide it up, then we end up with decimals, and those are no longer whole numbers. There's technically another category that we're not going to worry about, but under whole numbers there's what we call counting numbers, and it's all the whole numbers except they leave out 0, and we don't want to leave out poor 0, so we're going to just talk about whole numbers. Okay, so whole numbers falls within integers. Integers are very similar. The definition is whole numbers and their opposites. So 3 and negative 3, 5 and negative 5. So our negative whole numbers are our integers. So negative 3, negative 2, negative 56. Okay, those are all integers. Whole numbers are also integers, but integers are not whole numbers. I hope that isn't too confusing. But integers include all of our whole numbers. That's why the whole number circle's inside. And then we have the negatives, which are not included in the whole numbers, but they are included in the integers. And then out of here, we have our decimals. So if we had 3.25, that's a terminating decimal, so that's a rational number. 1/3, which is the same thing as 0.3 repeating, those are both rational. Negative 6/7, any of these are rational numbers. We can write them as a ratio of 2 integers. Okay, so we just want to be able to classify these. So if someone gives us a number like, oh, let's just say 3, okay, and then they say, well, what kind of number is that? And you say, And this is going to happen all the time to you. You're going to go into a store and they're going to say, what kind of number is that? Because they're testing you. Just kidding, that'll probably never happen. If it does, I want to hear that story. 3, it's a whole number. Okay? But you're not going to stop there. You're going to say, that's a whole number. Where, why? Oh, there we go. Sorry, my pen stopped. My computer is tired, I think, because I've made a lot of videos today. Let me see if I can get rid of some things. Okay, maybe that'll help. Okay, pen. So that's a whole number. That's supposed to be an M. A whole number. Okay, but not only is it a whole number, it's also an integer. And not only is it an integer, it's a rational number. And not only is it a rational number, it is a real number. Okay, so when someone says, well, what is that? And you're going to say, if it's a whole number, if they say, what is 3? You're going to say, oh, that's a whole number, it's an integer, it's a rational number, and it's real. It's a real number. Okay, so you're going to start at you're going to find where your number fits in this little diagram. The book one's a little bit better because they can draw better ovals because they used a computer. I guess I'm using a computer. Anyway, whole numbers, if it starts in this one, it's everything in this circle and above it. So whole numbers, integers, rational numbers, real numbers. If instead they said, how about -6/7? Well, that's not an integer, it's not a whole number, so it's just a rational number and a real number. Okay, with that in mind, everything that we're going to do, because we're not really going to talk about, if it's not a real number, it's what we call an imaginary number, which is something like the square root of -1. That is an imaginary number. We're not worried about those right now. If they ask you to classify any of the numbers, make sure you write down real number, because that's going to be part of it. They're all going to be real numbers. Now the rest, so if it's an irrational number, it's an irrational number and it's a real number. If it's a rational number and it could be an integer, it could be a whole number, that one you're going to